RAS bending. Parts bent with radii are suitable as design or functional elements. Components with radii can give building supports a special optic and machinery cladding a unique look. Small outside radii create smooth transitions and prevent sharp edges. Inside radii simplify cleaning, as is often desired in clean rooms or the food industry. Very small radii can even be used as hinges. How are these radii created? With folding machines, the formation of radii can be done in different ways. If the same radius is always required, a specially manufactured radius tool will bring the fastest results. In this case, the machine must be able to position the lower beam and folding beam to the proper pivot point. The folding motion pulls the metal around the radius tool. Due to strong material springback, significant overbending is required. Before the folding beam swings back to its home position, it moves away from the curved radius to minimize scratch marks on the surface. Sometimes you need a tool with a small radius due to the material properties. For example, sheet metal producers will suggest a minimum bending radius for aluminum used in roofing and facade industries. However, more often a procedure called step bending is utilized. This allows sharp edge bends and radii to be combined into a single process. The radii are created by stringing together short bending segments. Special tools are not necessary for this method. Using small step lengths, like what can be seen on the part on the left, create radii whereby the transition from one bend to the next are not optically noticeable. Should the radius be needed for a purely functional purpose, larger step lengths can be used as seen on the right. Even pre-coated sheets can be formed in this way, with appealing radii. When the folding beam is positioned to a larger angle, the bending radii become smaller. For thin sheets, the folding beam remains at its programmed angle, and the upper beam forms each bend during its closing motion. For thicker metal, the folding beam swings to the required angle for each bending step. When step bending, automatic positioning using suction or a manipulator is especially advantageous. The automatic advancement of the sheet accelerates the bending sequence, avoids manual reposition errors, and even allows large and small radii to be bent in the same sequence without interruption. The software calculates the required number of bending steps, the step length, and the angular position of the folding beam for each radius. Material-related influence on springback are also considered by the software. This procedure guarantees exact bending radii that speed up the assembly of components and leaves nothing to be desired in terms of repeatability. Folding technology with radii. Flexibility without effort.